a trig identity here. So they've given us one side is equal to the other. So it says, the left side, which is cos squared x, is equal to the right side of the equation, sine squared x plus 2 cos squared x. Is that right? Sine and cos? Yeah?
Yeah.
Okay, and then minus 1. So we need to figure out how to turn cos, or sine squared x plus 2 cos squared x into minus 1 into cos squared x. Because I thought this was going to be a factoring type question first, because this kind of looks like it could be set up like a trinomial, right? But I have cos and sine, which are different, and because those are different, we can't really include them into like a factoring a normal trinomial. So there are lots of different strategies to this stuff. One of the strategies is, the left side is cos, so there's only one there, so we're going to work with just the right side. And I'm going to start trying to convert, my sine into cos and all my other values into cos as best I can. That way I'm only working with a cos value. So there's a couple ways I can look at this. I can, if we know there's a Pythagorean identity, especially because everything is squared, there's an identity that says, and it's hard to read there, I know. You can even zoom in. Do we get a zoom? 200. Hey, not bad enough. A little more. Zoom, 300. Okay, super close. Let's go and read that now. Should have prepped this earlier. Come up. There we go. Okay, so we have sine squared x plus cos squared x equals 1. That's probably going to be the one we're going to be working with this whole time. Let's go back to page 1. Okay, good. So, and I'll write it here so it's easy to read. Sine, excuse me, squared x plus cos squared x equals 1. There's a whole different bunch of ways we can look at this. We can say 1 is equal to sine squared x plus cos squared x. You can say sine squared x is equal to 1 minus cos squared x. And you can say cos squared x is equal to 1 minus sine squared x. Like 3 different ones just out of that one Pythagorean identity. So I can go about, I can start finding relationships like, I know that sine squared x and negative 1. They can probably help us work out together. Or I can just start substituting values. I know that sine squared x is actually equal to 1 minus cos squared x. I know that 1 is equal to sine squared x plus cos squared x. So I can start substituting like values in for those, okay? What I'm going to do is I'm going to start with sine squared x. We're going to replace sine squared x, so just that value there, with what we have over here, 1 minus cos squared x. So 1 subtract cos squared x plus 2 cos squared x minus 1, okay? So I can start collecting my like terms. I have 1 and negative 1. Well, together they create a 0, so they disappear, okay? And then I have negative, and think of this kind of like negative 1, as if there's a coefficient there. Negative 1 cos squared x plus 2 cos squared x. Well, negative 1 and 2 is just 1, so 1 cos squared x, and I don't really need to include that one, so I have cos squared x, which is exactly what my left side is, okay? And this is a short way to do it, and there are many other ways. Let's see if I decided to change the 1, if that would have been helpful, okay? So let's say we repeat this. Squared x, sine squared x plus 2 cos squared x minus 1. So instead of working with sine, let's say we replaced 1 with sine squared x plus cos squared x. So a little more work. So we have sine squared x plus 2 cos squared x minus, in brackets, sine squared x plus cos squared x, okay? So we did that instead. We replaced that 1 value. I have negative 1 on the outside. Think of that like negative 1. So I have to distribute the negative to both of these before I can drop the bracket. So I get sine squared x plus 2 cos squared x minus sine squared x minus cos squared x, okay? So a different root. Let's start collecting like terms. Well, sine squared x and negative sine squared x, they eliminate each other. They create a 0. And then 2 cos squared x minus, and again, that's a 1. Cos squared x, well, that ends up as just cos squared x. So, different routes you can take. There's many, many different ways to get there. Sometimes one is faster than the other, but all are technically correct.